Right, we're back here in the stream, and we're going to continue. Be part 2 of our DMVPN, our VRF-aware DMVPN lab, and this will be the configuration part. So we've already gone over during the last stream. We went over the configuration, the requirements, etc. So now we're just going to review, or actually do, the configuration. And I've been thinking about this a little bit, during lunch. I didn't realize it. I don't know. I guess I thought that this lab wasn't going to take that long, so I kicked it off before lunch, only to realize as I got into it, it's going to take a little while. So we had to break it up into 2 parts. But I've been thinking about it during lunch, and I'm thinking about which order we want to do this in. And I think it would make the most sense to do the VRFs first, kind of the way the order is configured here, where we pretty much get our core working first, and then we focus on, in other words, so step 1 is we're going to configure our VRFs, our physical interfaces, quote unquote. Then we want reachability through the core, basic reachability through the physical interfaces. We're going to have some static routing that will help us do that, and then BGP. Then I think it would behoove us to go ahead and do DMVPN, and I'm not sure about this order. I may do DMVPN or IPSec, then DMVPN with IPSec, then EIGRP last. So that will probably be the order we do it in, but here we go. We're going to do our VRS first, and this is already loaded up. This particular configuration is, here it is. So we have here the DMVPN topology loaded from the Git repository. And just checking here, different windows. Got a lot of windows open, folks. Hopefully this will be somewhat manageable. Yeah, I've got some configuration docs here. This is the dynamic multipoint DMVPN. I believe this has a section. Yeah, this is a config guide. Secure connectivity guide. And in here we have DMVPN. I'm just kind of lining up what configuration documents I want to have available when we start to do this configuration, right? For the new stuff. So the new stuff for me is, I thought there would be something here regarding how to configure, yeah. Okay, yeah. Configuring the forwarding of encrypted tunnel packets into a VRF. So, and we're going to have, what's new is going to be this tunnel VRF command for us. Wow, it's got a lot of stuff on here. But we have this. I have the packetlife.net, which was referenced in, will be referenced in the description here. And we have some good examples here. Yeah, shared tunnel protection. So here we see, this actually has 2 tunnels, which I was thinking about. I may want to do this later because this particular configuration has a single tunnel from the spoke. But wouldn't it be cool once we get this working to actually do 2 tunnels so that we actually see the separation of traffic? So I'm probably going to do something like that towards the end of this lab. But we're going to keep this handy, and then the other component that we're going to need a little later is the BFD, which is brand new for me. So that'll be good. All right, so let's start laying out I want to try to do this all in a single document. So let's start with, let's see, we're going to have router 5. We're going to do a lot of router configurations. The only ones we won't be touching, I think, are 8 and 10. So let's go ahead and set this up. So we'll go ahead and do router. We'll put them in order here. Router 1, router 2, 3, 4, 5, 6, 7, and 9. So these will be all our routers here. 1, 2, router 3, router 4, 5, and router 6, 7, and 9. Okay, so there we go. And when thinking about this, we want to do our VRFs first. So we're going to focus on router 5, 6, and 9. And let's go down to router 5. We're going to say, let's see if I can remember some of this. I'm going to go ahead and load a router or a terminal for router because some of this configuration I'm a little rusty on. And I may need to actually use a command line to help me. So router 1, 2, 3, 4, 5, 6, 7, 8, 9. And what are we on? Router 5. Yeah. So let's go to router 5. And I believe we want to say IP VRF and then the name. Yeah. So we're going to do IP VRF underlay underscore transport. And the RD is 1:1. That's what it wants us to use here. So we need that on 5, 6, and 9. And actually, we have to put this on the interface. And on router 5, this is going to go on GI0145. So we're going to say interface GI0145. Now, of course, if we do IP VRF forwarding here, actually, let me think about this. Underlay, right. So this is the underlay transport. We're not doing VRF in the overlay. So this has to get assigned to this interface here. And we know that as soon as we assign it, we're going to lose our IP addressing. So do show run interface GI0145. Yeah. So we need to put this here. We're going to say IP VRF forwarding GI0145. IP VRF forwarding underlay underscore transport. And then the IP address. So that will do router 5, 5 to 4. And we want router 6 is going to be on 2 links. So let's go to router 6. Also underlay underscore transport. And in this case, we're going to do 67. I believe. Let me look at router 6. Okay, this is going to be show IP interface brief. All right, so we've got show run. Yeah, 67. And then the IP address. And we're going to do the same towards router 1. So that is, I believe, interface GI01146. Is that segment? And this will be 146.6. Okay. That is router 6. And then we need to go to router 9. Last but not least, let's grab this to copy. Underlay transport GI0179. This is going to be 79.9. Okay. Very good. So that will be our virtual routing and forwarding instances. And on router 6, we need a loopback that is also goes in that VRF. Interface L, we'll call it 66. IP address 666.6.6.6. We need to do IP same, IP VRF forwarding. Back. Yep, and then put the IP. No shut. I'm trying to get a habit of doing this exit because of So many issues I had doing DMVPN and well, really multi-address family configuration mode in both EIGRP and BGP. Seems to be just more beneficial to use the exit command out of each configuration mode. All right, and then we got some static routes. So router 5, we're going to do IP route. To now this configuration, I have to think. I believe this, we want to say VRF. We want to send this out the interface. Underlay transport. Is that how we do that? I believe it is. Let's check our example here. I don't know that we have a static route example here. We'll just have to check and see. Static route, default route. Yeah, so this should be in global mode. You know what I would like to see, just to verify, are we running any sort of other protocols now on router 9, or any other routers for that matter? Show IP protocols. Yeah, we're not there, and let's check router 7. Show IP protocols. Yeah, no, we got a blank slate here, pretty much, in terms of protocols. So now I don't remember if this, I never really did learn this like I need to. When you do a static route to a VRF instance, I think you have to designate in order to know the next hop. I need to look this up, guys. I need to look this up. So let's look this up. And I believe it's going to be under protocol independent routing. PBR verify, that's not really what we want. Multi-VRF support. Yeah, I really want to see an example. Yeah, that's running a protocol. Maybe we can find it under static routing. And that's probably under IP route. Yeah, let's see if we have an example of VRF here. This is redistribution. Yeah, that's not really a recursive static route, but let's do a search. So let's do yeah, not VRF Lite. I want to do this on Cisco. Configuring static routing. Okay, this I think is configure route leaky between global and VRF routing table. Yeah, so what we want is Here's an example. Host and LAN segment. VLAN 100. Okay, access list. Okay, that's importing a table. Yeah, that's not really what we want. Okay, between VRF and global routing. Yeah, this is... Yeah, what we're wanting to do is allow hosts outside the VRF to access hosts within the VRF. And of course, we don't have feature guide. Yeah, darn. You know, there was a question in the Boson exam that I missed about this. Route leaking by way of global to VRF. Okay, maybe this is what we need here. Global routing table, VRF. Yes, that's what we need. Okay, CPE. IPVRF, route target. We're not worried about this here because we're not doing BGP, VPN-v4 BGP. Okay, so here are two examples. Yeah, we want to go from global to the VRF. Okay, this is when we want to do from the VRF into the global table. Okay. The static routes can now be distributed to, now it's the same applies as a LAN interface. The IP address configured after the interface name is only used by ARP to know what address to resolve. Yeah, this is the part I was unsure about. By default, Cisco accepts static VRF routes as configured. Route leaking between different, you can use a no, okay. Now, it makes a distinction here between a serial and an Ethernet interface. Okay, this is going into the global table, so I think this is all we need. We're going to start with that, and we actually may go ahead and do this configuration and just make sure it works. Oh, yeah, absolutely we are. Absolutely we are. Okay. Static route, default route in VRF to router 4, okay, and router 9 is also, we want to do the same. So router 9. And router 6 loopback, okay. All right, these are our VRFs. Let's go ahead and put these bad boys in. And let's see if we got our config right here. These are expectations. Actually, guys, I'm going to save this as a new. This would be cool to do compare before after. VRF-aware DMVPN expectations before. We'll kind of use this as a checklist to sort of test our knowledge. Yes. Okay. So let's go to router 5. Okay. There's a problem with their IP route. First, let's just verify. Do show IP VRF. Okay, good. Router 5, yes, we only need a one interface. Now let's look at our route. IP route. And this is in the global routing table. Okay, we cannot. So if we want this to. it looks like we have to specify, let's find it. Here's an example. Yeah, we have to use the interface next, right? So the physical interface is J0145. But how do we tell it to use the VRF? Yeah, that doesn't seem like it's right. I know I'm kind of guessing here. Yeah, this is supposed to be in the global routing table. How do I let's see. All right, let's look at this example. IPVRF-VPN 2. So this has a regular route. I guess we need a route back in, don't we? (10.1.2.4). 10.0.2.0. So we're going this way. So this would be like CE4 in our example here. But we are router PE4 will be router 5. So 10.0.2 is going that way. So in this particular case, this will be our GI0145. So we have a global IP route. In this case, it will be default. We'll go out that interface. Okay. But then do we need this coming back? We don't, because we're not trying to go route to another segment. All right, well, based on this example, all I need is this. And I'm using an interface here because obviously we want traffic. Default route without gateway, not a point-to-point, may impact performance. Specify name of the next hop. Forwarding router's address. Okay, I'm going to leave it at that. Seems like I'm missing something, but we will go with this for now. Let's see, that's router 5. Then we need this also on router 9. We'll see if it works. We'll know in a moment. And this will be GI0. Okay, so let's put, that's router 5. Everything else took. Let's go to router 6. Okay, like that. Loopback is up. And we'll go to router 9. Default route without a gateway may impact performance. Yeah, I understand. All right. Show IP route. This is interesting because what this is saying, I believe, is if we're just talking about IPv4, normal traffic means we're going to have to do a ARP for any destination. We're going to have to do an ARP. But in reality, we're going to have to do a discovery, right? An address resolution protocol. And that's okay, because we're going to be doing that anyway with NHRP. At least that's my theory at this point. So let's try it out. Let's do show IP route. And what is something that we can attempt to access here? So let's say we want to go to yeah, I don't guess 6 will be able to route back to us yet. So just to make sure our route is configured right, let's do a yeah, I don't think this is going to resolve, because if router 7 IP route, there's no routing protocol running. But let's see if we can at least get to, for example, 155.177. Let's try that. Okay, ping. Yeah, no, we're not able to get back. Okay, so we need to check on our if we look at our diagram, we're going to have reachability to the underlay network. VRF underlay transport, router 5 is linked to router 4. Router 6's links here. Router 9 is linked to router 7. Okay. So for these VRFs, we really don't have a way to route between these yet. We don't have a way to test this. So I think I'm going to have to move on. Once we get BGP running, let's see, because BGP, let's see, where are we going to advertise? Okay, we're going to advertise a link to router 5. We're going to be advertising these links. So then router 6 should be able to, then we'll be able to test our VRFs. All right, so we can't really test our VRFs yet because we don't have reachability through the topology. And that's what BGP is going to help us do, right? So let's move on to our Bgp configuration. And let's start with routers 1 through 4. So I'm going to move this over here. And we need to do something with this here. I know that's big. I need to, sometimes I fear that these things are really visible on the screen, but I forget. Some of you might be seeing this really large screen, so we should be fine. All right. So we need BGP. I can basically go by this diagram here. I don't have to have this window open as well. Unless I want to make it really small. We can reduce the size just temporarily. Yeah, let's do that. That may be hard to read at this point, guys. I apologize, but can't be helped. If you're like me, as you're getting older, you get a little blinder, but comes with the territory. Hopefully a little wiser too. But anyway, all right, so we're going to configure, we'll just go in order here. So we'll start with router 1 and router 4. And we'll say router BGP 100 and router ID 1.4.4. And let's see, neighbor router 1 and router 4 are going to be neighbors on, I'm assuming this link. Surely it is. So we're going to use our should we do loopbacks? Yeah, why not? Let's do loopbacks. So neighbor, this router 1. neighbor 150.1.4.4, remote AS is 100. And we're going to say neighbor 150.1.4.4 update source L0. And address family IPv4 unicast. Network, what were we supposed to advertise here? So the purpose of this AS is to provide transit for this traffic here, right? Through this cloud. So I think what I'll do is just let's just do 155.1.146.0 mask 2525250 network. Basically the underlay transport, we need to advertise all those links, I think, in BGP. Network, that's the link between these routers. But let's also make him aware of this link as well. This link will be in our transport too. So we're going to do 151.13.0 mask 255.255.250. And what else? We'll advertise our loopback. I don't think it's important in this case, but we're going to do it anyway because that's our standard. Mask 255.255.255. Now, I think this is, are these /32s? I believe they are. Show run interface L0. Yeah. So that will be this neighbor, and then that'll be router 1 in AS100, and then we're going to come back to him because I believe he has some, he's got some eBGP neighbors too. But we'll come back to that. Let's go ahead and do iBGP first, just to keep our sanity. And we don't need to copy all those lines. This is also going to be router BGP 100, 50.1.4.4, 1.1, and 1.1. The thing is, this is iBGP. I'm just thinking about these loopbacks. We don't have an underlying protocol running here. So there is a danger of using the loopbacks. In fact, this is a very simple design. And we're running BGP with no... So we cannot assume reachability, to be honest. I'm rethinking that. As a matter of fact... yeah, let's take this out. Let's take this out. If we're running iBGP, even RIP underneath, I would feel confident about that, but I really don't. So we're just going to not worry about the loopbacks in this particular configuration. Neighbor 150.1.4.4. In this case, we're going to say neighbor 155.1.146.4. Right? And these are networks, physical networks. Now we're going to worry about loopbacks in the underlay network. All right, so coming back to router, that's router 1, come back to router 4. We're going to keep that router ID, it doesn't really matter, it's not reachable, it's arbitrary. Neighbor is going to be, in this case, 155.1.146.1, remote AS, same. And we're going to take this out. And on this one, router 4, we're going to advertise this network, and we're going to advertise network 155.1.45.0. All right, this is a key one here, right? Because that's going to be part of our customer traffic. Okay, we could, I mean, it doesn't say we have to do this. Here in our requirements, it doesn't say, okay, you need to be running a, you need to run an underlying IGP protocol. It doesn't say that. So we're not going to go ahead and do that. But otherwise, that's what I would typically do. Like I would inside this area, I'd run RIP or something like that. EIGRP, really, or OSPF. All right, so that is our first AS. Let's do AS 200, which is here. So this router is 3 and 7, and kind of similar. But this is 200, 150.1.3.3, and these segments for router 3, we're really only concerned about these two networks here. So we're going to say our neighbor is going to be established TCP session over this link, 151.37.7, remote AS 200. And our networks are 13.0. We need that one, but we also need 79.0. Okay. Then same for router 7. I'm trying to think. It doesn't look like. Yeah, we're going to need 3 network segments in router 7. On router 7. So I didn't need to copy all those. That's okay. 150.1.7.7. Neighbor, in this case, yes, 37.7, 37.3, remote AS 200. 79.0. Then we have network 15.1.67.0. Network 151.79. Let's see, I have 79, don't I? Yeah, 79. This one. 37. That's what I'm missing here. Let me look back at router 3. Now I'm doubting what I did. Yeah, I don't know why I said 39 here. It's 37. Okay. So that is AS200. I believe that's everything. How many segments we have for this neighbor? Yeah, 37.3. Okay. Okay, now AS6. So that is router 6, of course. Router BGP 6. And router ID 150.1.6.6. Neighbor. This will be for eBGP. So let's go ahead and work on this now. Let me see here. 1 to 4, 3 to 7. Okay. We got to come back and do some eBGP, but at least we'll start with router 6 as our first eBGP configuration. So he is going to be first neighbor will be router 1, and that will be 151.146.4. And remote AS is 100. And let's see here. What else? Yeah, address family. IPv4 unicast, and our networks are going to be 151.146.0 and network 67.0. It also says here that we want to advertise a new loopback. Which is interesting, right? Because that's the VRF. So I believe all we do here is just network 6.6.6.6. Okay. Link to R5, advertise R9 link. Okay. I wonder if it's just limiting us here. Yeah, I'm just going to try to make this simple. So router BGP 6, that's our first eBGP neighbor. And we're going to say, what else? router 1 and router 7. Okay, so we also have neighbor 15.1.67.7. Remote AS is 200. Okay. And we'll use the same networks here. Okay, so that's router 6. Now we've got iBGP going here. We've got iBGP here. We need to come back and do this eBGP peerings. So this will be router 1. We're going to also have neighbor. And it's router 1 to router 4 and router 1 to router 3. Yeah. Neighbor 15.1.13.3, remote AS 200. And we're going to put this neighbor here in router 3. This will be 13.1. Networks should be the same that we're going to advertise that way. Okay. And then we've got router 6 to router 1 and router 6 to router 7. We have those in there, but this is where we come to the point of BFD. So I've never done this before, folks. Bear with me here. But we're going to look this up. And this should be, now let's see, where will this be located? Oh, it has its own guide. Check that out. Yeah, so BFD. This is something I'm very interested in for a number of reasons, work-related and otherwise. But here in the INE videos, this is a section we talked about a little earlier where actually this is done. So we've got in our future videos, convergence optimization. 5 videos. And I have not watched this one yet, so hopefully I'm not getting too far ahead of myself. I probably am. But in my defense, I did not realize that I was going to have, that BFD was going to be a requirement of this particular lab. So, you know, we may, depending on how deep this gets, we may not even worry about this particular feature right now. So yeah, I've not even looked at that, but here we have a BFD configuration guide. We've got, you know, a lot of times at the top of these guides, you have your basic guide here that has the generic configuration. Then we've got some other things here, static route support, IPv6, BFD CBIT, multi-hop for IPv4 static routes. Okay, good. That's all good. But let's just look at, I mean, I know essentially what this feature does. And usually, as I understand, what this feature is for primarily is when you have, typically, you'll have an eBGP peering like this. Router 3 to router 1. Or even router 9 to router 7, for example. CE to PE router. And you see that there's a physical, you know, typically it shows in the operating system anyway as a physical link, like in this case. But that doesn't mean you might have layer 1 connectivity. Like you might have, you know, when you do a show interface, for example, show interface GI01146, line protocol is up and the interface is up. Problem is, this can be deceiving because in reality, when you're dealing with a provider network, you often have, you could have some sort of hub or fiber repeater, signal repeater, or media converter to where the interface signaling shows that the physical interface is up, when in reality, you may not be. Maybe you don't have, maybe the other interface on the other end is down, the PE router is down. But because you do not have a true physical link point to point, then this may be up and you have to, in that case, BGP will not time out if you're using default timers. What is it? 150 seconds. So you're gonna have to wait a long time, even though you truly don't have physical 1-layer connectivity. you know, you're going to have a convergence event, but it's going to take a long time. So bidirectional forwarding detection is there as a stopgap. It's to basically check through the medium to the other side to ensure that you're up. And when you're not up, BFD will give a signal to the route processor that this session, this link is down, even though the interface is up. So that's my understanding of the intention of this protocol or feature in a nutshell. And I don't think there's a lot to the configuration here. BFD interval. Yeah, so configure BFD session parameters on the interface. Steps. So configure the IP address for the interface, and then you do BFD interval, blah, blah, blah. This enables BFD on the interface. The BFD interval is removed when the subinterface, which is configured, is removed. Right. Yeah, there's some guidelines here about how it is used. And this is for static routing, IP route, static BFD. Now, this is interesting. We're not doing this in this case. IP static route, show IP static route BFD. Interesting. I didn't know you could do this. Again, I have not gone over this section. So it looks like we turn it on for the interface and we use an interval. There's also a slow timer. All right, let's go up to the prerequisites here. Yeah, Ceph and IP router must be enabled, must enable parallel expert on the blah, blah, blah. One of the IP must be configured on the routers before BFD is deployed. Router must be run via BFD must be single IPv4 single hop. There are, of course, restrictions. Support for tunnel, that's cool. And there is support on Dmvpn as well. All right. So you configure the session parameters on the interface. And then it sounds like there's a configuration that takes place in the protocol. Let's see if there is a quick reference here. Configuration examples. Okay, here's an example with EIGRP network. We want an example with BGP. I wonder if it has one for that. Okay, here we go. Configuring BFD in a BGP network. So here's a fast interface, and we put a BFD interpol. And fall over BFD. Nice. Okay. All right. And then we configure it on both sides. All right. So let's take this example, folks. Actually, let's move this to the side. And we will configure this on what are requirements? Basically on router 6 towards router 1. The router 6 eBGP peerings. So we're going to do on the interfaces here to router 7. BFD interval. I'm assuming this is milliseconds. So I'm going to take the defaults here, or the example. This says fast interface. Is there a way to configure it without? Let's see. So we're going to do this on router 6. Interface GI0 1 146 BFD. Okay, interval 50 is the lowest. So, all right, we'll do 50. Excuse me, this is a virtual environment, so let's do like 100. So 100 min RX, 100 multiplier. Multiplier 3. That seems reasonable. That sounds like a lot like, multiplier 3, probably an SLA configuration. So we want to do this on 67 and 146. Sorry about that. Yeah, so we want to put this on both sides. So let's go to, for router 6, his peers are going to be router 1. And wait a second now. Is that right? Okay, I have not configured that part here yet, so. Yeah, I configured router 7, didn't I? No. Router 1 to routers 3. Okay, I've not. All right. Neighbor 151.146.6, remote AS is 6. And neighbor fall over BFD. And we need to put this on the interface as well, which is interface GI 0, 1, 146. Now this is interesting because we're going to have BFD running. But this assumes we will actually have 2 neighbors on this. So how do we configure it on an Ethernet segment? Point to point makes sense. It should say prerequisites. One of them must be configured before BFD is deployed, of course. Restrictions, these are basically platform. BFD is not supported on IPSec. Oh, directly connected neighbors, no more than 1 hop. I'm not seeing anything about Ethernet versus point-to-point. So BFD interval multiplier, yeah. All right, well, let's just do it towards that interface, even though we're not using BFD between router 1 and router 4. That's okay. I guess. We'll find out. So router 1 towards router 6, follow BFD, and we need to put on the interface. What do we use? BFD interval 100. Don't remember the syntax. Yeah, BFD interval 100 min RX, min receive. That must be transmit, receive, multiplier 3, I'm assuming. Okay, so that is between 1 and 6, and we have BFD here. Now we want between 6 and 7. So let's go to router 7. I don't think it's been configured on this side either. Yeah, neighbor. 151.67.6 remote AS of 6 and neighbor 67.6 all over BFD. Okay. Then we need to put it on the interface GI0167 BFD interval. All right. That should be BGP, folks. Should be our BGP configuration. Let's look back at the requirements. If we missed anything, router 6, router 1, and router 7. We are going to be advertising these and other links. We basically have somewhat of a, we have no IGP running here. So we should be learning, though, with this configuration, all the routers should be learning about the segments that it needs to do this customer routing. And maybe a few more that they don't, but we'll go with that for now. All right, let's test this out. Let's go ahead and enter the configuration on router 1. See if it takes. Cross your fingers. Get all good bits. Nope. Router ID is not super important. But what did I do wrong? Router BGP 100. BGP router ID. Okay. We need to come back and do that. Let's do a... Oh, I did not want to do that. Come back. Yeah, don't disappear on me. That was a lot of work. I'm trying to treat this like Notepad. But we want to do a find and replace. Yeah, it's different. So we want to do, in this case, router ID, and we want to say BGP router ID. Replace. Okay. All right, that was router 1. Let's go do router, let's see, what's the next one on the list? Router 3, okay, good enough. Took. Good. All right, router 4. Okay, we got an issue here. I think I had some of these in the wrong order. He doesn't like the AS number of his neighbor, 113 from 13.1. Why is that? On router 3. Remote AS 100. Okay. Fair enough. No router BGP 200. Let's do this. Okay. Yeah, we got neighbors there. Okay. Now router 4. Good. And router 5. No BGP running on router 5. Router 6 has it. Did I not put BFD on the interfaces here? Oh yeah, I need to add that as well. Somewhat repetitive, but that's fine. Okay. And router 7. Okay, and then router 9. Yeah, okay, we're good. So now we should be able to actually verify. We see our adjacencies coming up, and we should be able to verify our VRF routing, because now we should have learned, we should have transport, basically. We should have transport, at least physical transport to the hub, because that's what we're going to form our DMVPN tunnels over, right? So let's go to router 9. And he just has the default route, right? So router 7 should have, yeah, he's learned some routes now. I noticed that he has not learned the loopback. Yeah, that's kind of a new scenario for me. So, all right, let's just see what we got anyway to the VRFs. So do we have the... All right, let's go to router 6. Need to kind of review a little bit. It's been a while since this is before lunch, so the VRF. Okay, IPVRF underlay transport. And that is assigned to loopback 66 and J0167. So can router 7 ping that? You can. Yeah, something's not right about that. He doesn't have a route, even though router 6 is supposed to be advertising it. I'll bet we have to go into VRF mode here. That's probably what we need to do. So let's try that. Let's go to router 6. Router BGP 6. And let's say address family VRF VPN, no, VRF PV4 VRF underlay transport. Then we have to activate, right? Neighbor 151. Who are our neighbors here? All these guys. Yeah, that's what I'm missing, I believe. So yeah, we've got to do neighbor 151.146.4 activate. We don't want a peering. Right. We don't want a peering to this. We just want to advertise this network. Yeah, I don't think I'm getting this right. Network 6.6.6.6 masked. Let's see if that made a difference. Show BGP IPv4 uni summary. Message sent, prefix received. None. Table version. Okay, show BGP IPv4 uni all neighbor. Um, 67.7 advertised routes, none. Interesting. All right, I think, yeah, I'm definitely not doing something right here. Let me look at some of these examples that we have from the packet life. Yeah, okay. Let's look at this example, folks. So multiple DMVPNs on a single hub. Here's customer A. I think this is going to be different. Head-in routers, customer A routers. Yeah, the tunnel interface is a VRF. You know, that would seem to make a lot more sense. Like, I'm not sure why. Interface T1. He's not showing me, though, the... Yeah, this is really unfortunate. This looks like it could have been a really good article. It does not, however, show the customer the full configuration here. Here's the other thing, folks. There was no video for this. There was no video how to do this for VRFs. Just kind of threw this one out here. But so I feel okay to go ahead and look at part of the answer key. I don't like doing that, but I don't have much of a choice here. So let's pull that up. I thought I had it open somewhere. Oh, I do. Okay. Let's just look at router 1. Oh, that's interesting. Okay. No, not router 1. I want to look at router 9. And okay, IPVRF forwarding. Okay. So I have the I should have used the other example of IP routing. So this is incorrect. The static route. Yeah, this needs to be IP route VRF underlay underscore transport. You know, that makes sense when I see it now, because it's not in the global routing table. It's in the VRF routing table. So we're not doing any global routing at all, it looks like. All right, let's look back at the, I don't want to look at like all the details of the, you know, I'm trying to sort of hide, but look at the same time. Let's fix this too, router 5. So this will be IP route VRF underlay underscore transport 5.1.45.4. Yeah, right. Okay. So let's fix that now. That should make a difference already. Show run route. Yeah, let's take this out. And copy this. And same with router 9. Let's clean this up. Yeah, I knew in my heart this was not right. So the example we looked at before, the other Cisco doc, it had a good example in there. It really did. Okay, so we have our route in there now, and that's just for VRF. So let's look at the other question I had. Was router 6. And okay, interface loopback 6. The BGP section is what really interested me at this point. Okay. So we're not doing any global BGP routing. So I'm going to do this. No BGP router 6. And then address router BGP 6, address family, IPv4, VRF, underlay transport. Yeah, it makes more sense. Okay. It does make more sense. Then we do our regular neighbor 67.7, remote AS200, neighbor 151.67.7, all over BFD, neighbor 5167.7 activate. Okay, that makes sense because we're under VRF mode. 51.146.1. Can't spell neighbor. Neighbor 151.146.1, fall over BFD. Yeah, see, that's what that's what was not making sense to me. Is it seemed like we were associating the VRF with the physical interface going this way. But it just seemed to me that we wanted to establish adjacencies to... Yeah, okay. VRF, not VRF. So we're not going to communicate to the global routing table here at all. We're going to be VRF'd here, and we're going to be virtualized here and virtualized here. Yeah, this is the part I guess that was kind of throwing me off because this is in the middle of the topology, but it's still going to be essentially virtualized. Okay. All right. That makes a little more sense now. I think I can move on from here. So let's adjust, let's fix this. We already fixed the static route. Now let's fix router 6. Let's just paste this whole. What do we do wrong here? Neighbor activate. Oh, I have a typo, I think. Neighbor. Remote AS 100. Where did we go wrong here? Neobor. That was a hard one to see. Okay, let's just put that one back in here. And I still have a typo. Gotta watch those darn typos. Death by typo. All right. Exit. Interesting. Exit address family is death by hyphen. All right. Okay, here we go. Our VRFs are up, our neighbors are up. All right. So we're not really communicating at all with the global routing table on router 6. This is an interesting design. Yeah, interesting design. Okay. Now let's see if we have connectivity. What routes are we learning in BGP? Let's take a look. What happened to my terminals? Here we go. So router 6 show BGP, IPv4, VRF, underlay. Darn it. On an ASA, it will fill that out for you. Show BGP. Uni. Let's do all. All right, what am I doing wrong here? Show BGP. Okay. I have to do that first. All right. IPv4. No, all. All right, what am I missing here? Show BGP, IPv4, unicast. All right, there's no place to do VRF here. So we have to do show BGP, VRF, underlay underscore transport, question mark. There is no IPv4. All. Summary? Oh, all right, there we go. Yeah, I always wondered why don't they have unicast there? You really have to do all. Just got to remember that. Got to get that in my head. Boom. Okay, so that's interesting. It puts it in the VPN v4. That makes sense. VPN v4 unicast, because once you're dealing with VRF, then you have a different format of the BGP packet. You're now in VPN v4 mode. Even though the configuration is not address family VPN v4 VRF, it is address family IPv4 VRF. But when you do show BGP, you have to do show BGP VRF VPN v4. I mean, all works, but I want to know what to use here. There we go. See, that's... why is it that way? Why would you not enter it in as address family VPN v4 VRF? Okay. Anyway, we have our neighbor adjacencies. We have prefixes. So now if we do show BGP VPN v4 unicast all, here's our routes. Nice. So question is, are we now learning the new loopback 6.6.6.6? Let's look at router 7. Show BGP IPv4 unicast summary. And we have two adjacencies, which is good, AS200 and AS6. So show BGP IPv4 uni. And we're not yet learning 6.6.6.6. Let me check that and see what I may have wrong there. Did I not have a network statement? VRF forwarding. I'm missing a network statement. Of course I am. As a matter of fact, it did not have... it's only doing... network 6.6.6.6 mask. All right, so let's add that. Okay, now we should be advertising it. Okay, so let's go back to router 4 or 7, and there it is. All right, we have reachability. Now let's go down a hop to router 9. Show IP route. Nothing, right? Show IP route VRF. Underlay underscore transport. That's a long name for VRF. And there we go. All right, so good deal. So now let's do ping 6.6.6.6. No, ping VRF, right? VPN underlay underscore transport 6.6.6.6. Good deal. All right, so now we have basic underlay reachability, right? Through our networks, through our remote sites and our hub. So now we can move on to the next phase of configuration. Whew. All right, we got through that. Are we running BFD? We need to check that as well. Let's go to router 6. I'm sure we can do show IP protocols. It's probably running under there. No, it doesn't. It does not show there. Show IP VRF underlay. Oh, it does autofill. Nice. What's the equivalent to show IP protocols or a VRF? Show VPN v4? No. IP protocols. Maybe there isn't one. Ah, nice. Ah, there we go. Does it show where can we show BFD? Show BFD summary. Okay, 2 sessions up. Show BFD map. No, we don't have a map. Show BFD neighbors. Nice. There we are. Up. Good. All right. Hey, we got BFD configured first time. All right. So now we can go to DMVPN. Let's just check the other side. Let's check router 5 and make sure he's happy. Ping 6.6.6.6. No, ping VRF underlay underscore transport. Yay. Okay. So now we can do our tunnels, right? Let's staple some tunnels down, people. Time to staple some tunnels. Get out your network staple guns. And let's do some work here. DMVPN. So that's obviously the next choice of configuration that we want to do. Router 5 and router 9 spokes will be sourced from the VRF and use IP addressing. All right, so I think this is very similar to our tunnel interface with the exception of just a few commands, right? And I need to hide this key. I don't want to look at the key anymore. So let's hop over to, I don't think we're doing anything on router 2. Let's start with the hub. And we're going to say interface tunnel 0. Now, this says source from the new loopback. And this says the source from the VRF. All right. So basically what that means is our tunnel interface. Now I'm going to try to remember the steps that I practiced before. We had this discussion in Discord and on stream about, okay, so do we want to memorize this configuration? And initially I got some feedback, said no, don't worry about it. You know, even Brian McGann said no, don't worry about it, just know where to find it. And then everybody else is like, no, 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 no. You need to learn this. You need to learn to memorize it. And you need to practice it. So this Dmvpn configuration, we are going to commit to memory slowly but surely. But essentially, what I've been told or suggested is to break it up into parts. So the first part will be to me, the IP addressing, right? So we'll do IP address 151.0.6. And we'll say tunnel source. In this case, it's going to be loopback 0. And tunnel destination. So in this case, we're doing DMVPN phase 3. So tunnel, actually we need to specify the tunnel type. Tunnel GRE multi-point. And then we want to say tunnel multicast dynamic. Yeah, I'm missing something here. IP address, tunnel source, tunnel type, tunnel map. We do our mappings. So tunnel map, we map our overlay, which will be, well, we don't map on the hub. We don't need static mappings on the hub. Okay, so these are our mappings. Oh, shoot, what else do we need? Tunnel mode GRE tunnel map, multicast dynamic. That should be all really the mapping that we need here. Let's look at our example. Okay, here's the doc. And I'm going to have to take a quick peek just to confirm. Yeah, we got our IP address. We do need to do our authentication, right? Our NHRP configuration. I need to think IP address, tunnel source, or tunnel type. I should do it in that order, right? Tunnel type, tunnel source and destination, and then the IP NHRP configuration. So IP NHRP authentication is, what is that? IP NHRP authentication, NHRP auth. It gives me a hint here, but I need to memorize this. RP network ID of 1. And yeah, we need the tunnel key. Tunnel key is going to be 2 in this case. Network ID, we are doing EIGRP phase 3. This is a phase 2 example, so we're not going to do that, but let's go ahead and put this in here. Even though EIGRP is later, to save ourselves a little time. No IP split. Well, no, this is multi-AF mode. Never mind. Tunnel source, tunnel mode, GRE multi-point, tunnel key. And we're going to put protection in later. So this should be our hub configuration. Let's see how I do on the spokes here, guys. I think I need also VRF forwarding here. Let me check my example, guys. I'm going to open up the packet life. Let's see. I'm trying to just look at history here. Let's go back to this so you guys can see what I'm doing. It's Leaky. Wow. All right, let me pull up the agenda then. I know it's in the agenda. Bear with me, folks. So many documents. So many documents. I already closed the agenda, but let's open it back up. Hey, Bravo saved me 10 minutes of my life. Okay, Packet Life DMV. I think this example will give us that much anyway. So yeah, when we go to, first of all, we need a key ring when we get to crypto. Yeah. So we have to put the VRF forwarding on the tunnel interface as well, right? So here, IP VRF forwarding, which makes sense because that's exactly, essentially whichever interfaces are involved in the VRF, it's just IP VRF forwarding, including the tunnel. Underlay underscore transport. Yeah, that's it. That is it. Okay. Now let's go back to one of the hubs, which will be router 5. And we're going to say interface tunnel 0. And let me try to think of this in my head, guys. So IP address first. 155.1.0.5. And the tunnel type, GRE multipoint, because we're doing phase 3. And the tunnel source, in this case, what did it tell us? I think it told us it wants to be the GI0145 from the VRF. Okay. And in this case, yeah, GI0145. And the tunnel destination, we're just going to say tunnel. I always forget that command. Tunnel map multicast. Okay, this is where we do our mapping. Because so I have to think, tunnel source, tunnel destination. In place of a destination in a DMVPN tunnel, you have to do the mapping, right? So on router 5, we're going to do tunnel map multicast dynamic. Actually, this should be a tunnel map multicast. This is going to be the underlay IP address. 155.45, 155.145.5. Okay. Tunnel map multicast 151.45.5. And then tunnel map 150.1.0.6. All right, I need to think about this. This is the underlay address that I'm going to connect to. And router 4 is not, this is not my outgoing IP address. This is the destination, which I will have learned about through, well, I have a static route going that way. So normally in the cases I'm accustomed to, this is the underlay address. So is that my immediately on which segment? Or is that the remote IP address that I'm trying to connect to? Let me look at this example and see if it sheds any light on that. IP NHRP map multicast dynamic. Let's look at the customer. IP NHRP map 192.168.1.1. 172.16.0.1. Okay, so that is the head end. That is a remote. And this is an IP-NHRP map command, not tunnel. So this is IP-NHRP map multicast. And this, the tunnel on the other end is going to terminate on loopback, on the loopback address. This is different too. So this will be 6.6.6.6. Right? Router 6. Yeah, this is all kind of different than what I'm used to. But this should work. This should work. Okay. Let me look back at router 6. I think I messed up on this. Yeah. IP-NHRP multicast dynamic. Right. Okay. Back to router 5. IP-NHRP map multicast, blah, blah, blah. IP-NHRP map. The 155.1.0.6 is the overlay, and then the underlay goes there. IP-NHRP next hop server is 155.1.0.6. Okay, I know I'm sure I'm missing something here. IP-NHRP key, yeah, tunnel key. Authentication. So we need IP-NHRP authentication, NHRP auth, IP-NHRP tunnel network ID, tunnel key of 2. Yeah, I need to get in the habit of thinking about when I configure the tunnel interface, IP address, tunnel mode, tunnel source, tunnel destination, which in this case would be NHRP, and then tunnel key, and then tunnel protection. Okay. Map, that should be good to go on router 5. Now let's go over to router 9. We probably should just go ahead and test that, but, you know, I'm feeling dangerous. Okay, IP address, 151.0.9. And tunnel mode, Jerry multipoint. Tunnel source, GI0179. Tunnel destination is NHRP. So it's IP-NHRP authentication. IP-NHRP server ID is 1, right? Network ID. IP-NHRP map multicast 6.6.6.6. IP-NHRP map 151.0.9. No. 0.6. IP-NHRP next hop server. Right. And then tunnel key of 2. Yes. Okay. Practice, 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 practice. That's what we need. All right, so let's put in the hub configuration first. Let's go and pop this in here and just do some validation. We've been here a while, eh, folks? Hour 39 minutes, and we're just now getting the DMVPN. This is a good one. This is a good one. I may do this one over. Well, I will definitely be doing this one over at some point. All right, so configure terminal. Let's see if he likes it. Okay, tunnel mode. Tunnel mode, Jerry multipoint. Not grep. Okay. All right, he likes that. Show run interface T0. IP VRF forwarding, IP address, blah, blah, blah. Good, good, good. All right. Let's fix this. Tunnel mode. Let's go up to router 5. I got tunnel mode in there. I'm not sure why I didn't do it in the other one. Ah. Okay, so we should be able to tunnel change the up. Ping 15106. (155.106) source T0. All right. What do we have happening here? Okay, so let's do some troubleshooting. Show run interface T0. IP address 155.105. IP NHRP authentication, NHRP auth. IP NHRP map multicast, 66666. If you're on. Hey, Dimitri, how's it going, my friend? I hope you had a good stream. I was watching part of it, just so you know, and I hosted you. My underlay is in VRF. Yes, it is. As a matter of fact, let me show you the diagram here. It's not a really good diagram, but basically this interface is in the VRF. And there's a loopback here on router 6. He is also in a VRF, and we have reachability. Oh, did I put the... I did not put it in a VRF, did I? Good hint. Good hint, my friend. I left this out. Yep. Oh, tunnel VRF command. IP VRF forwarding. Down here. Okay. All right. So would I use IP VRF forwarding also? This one is underlay. If the underlay is in VRF, you need the tunnel VRF command. Okay. All right. So on the hub, what I did is I did IP VRF forwarding, but you know, I should probably just look at your. I'll bet you have this in your presentation. I'm going to move it off. Don't worry. If it pops, no, it did not. Okay. Okay. So this is in your slide. The front door VRF DMVPN. Gotcha. What if the route towards NVMe address is in the VRF rib? Front door VRF DMV feature comes to the rescue. And Dimitri's presentation comes to the rescue. So yeah, notice you don't have IP VRF forwarding on the tunnel interface. Instead of using this. All right, let's switch that out. So let's do this. Let's do no. And we'll do tunnel VRF underlay underscore transport. All right, there we go. So let me correct that. Let me move this stuff out of the way here. IPVRF on the tunnel will put overlay in a VRF, but it may be needed if the task asks you this. Yeah, it doesn't specifically say that. It just says that it's sourced from the VRF. Yeah, that's all it says. So I'm going to try. Yes. So true. Spoken from experience, I'm sure. So I can't just come over here. I really need to paste this because if I were to just go to the router and do no IP VRF forwarding, boom, it's gone. Very true. So let's do that. Yeah, I could come in here just thinking, I'm just going to put this command. I'm done. And then walked away, right? Then you don't need to put, hey, I see you're using the, Emoticons, that's awesome. All right, so now tunnel VRF. Let's just put this whole thing in here. Okay, so that's my hub, and I'm going to drop back over to the spoke. And we're going to say, yeah, I didn't have anything in there. Tunnel VRF, which I already added. So let's do show run interface T0. All right, boom. Good. All right, so now let's try to see if we have reachability. Ping VRF underlay transport 155.1.0.6 source T0. One 15106. All right, let me check my interfaces. Ah, right. Your tunnel is not in the VRF. I see what you mean. Now I want... So let me just do show IP NHRP. Let me look at your front door VRF. Show VRF underlay transport. Tunnel is up. All right, let me think about this. Encapsulation tunnel. Multi-GRE IP. So does that mean... This is shown as a directly connected interface to the global routing table. Interesting. It is directly connected to the global routing table because, like you said, it's not... The tunnel interface is not in the VRF. It's only tunneling through the VRF. Ah, okay. All right, so I have some layers here. How do I draw this? I need to sort of visualize this now. Let's just use Notepad. So we have, for example, we have the tunnel interface. So let's say you have global routing table. The tunnel interface is part of that. Then the tunnel interface will run encapsulation towards, actually this, let me think about this. So we have the global context. We can go to the tunnel interface and traffic towards, let's say, for example, traffic destin, let's see, traffic source. You know what, let me look at my requirements here and double check, because EIGRP, the verification, our end goal here is that router 5, 6, and 9 can reach each other's loopbacks over the DMVPN network. Okay, the loopbacks are in the global routing table. The loopbacks are not in a VRF. Router 5 and router 9 will not transit the hub, right? We're phase 3. Ensure reachability is maintained if router 6 loses its peerings. Okay, so really, yeah, we want to source, for example, if we are on router 5 and we want to source traffic from loopback 0, And the destination is, we'll just say router 5 loopback 0 is the source. And the destination is router 9 loopback 0. So what we want the traffic to look like is for this to go to the tunnel interface, tunnel 0, to go to our VRF interface, to actually when we do a trace route, since it's going over the tunnel, it should, the next hop will be the tunnel interface will be tunnel 0 of router 9 to router 9 loopback 0. Right, that's our end result. When we do a trace route, it'll look like a single hop because we're going to have a spoke-to-spoke tunnel. And the tunnel, the GRE tunnel, so the GRE encapsulation is tunnel 0 to the VRF that is on interface J0145. And this is going to go through our network. Trying to think of the headers here. Right, this is actually going to have via the route distinguisher, right? It's going to be encapsulated with the route distinguisher. So then it's going to transit the network. At some point, we will form a spoke. We won't illustrate that here, but through NHRP redirect, we'll form a spoke-to-spoke tunnel. And this will end up coming into router 9. Let's put GRE encapsulation, let's say router 5. And then to router 5 VRF, transit network or transport network. This will come into router 9, the VRF interface, 0179. And then it will go to the tunnel interface. And de-encapsulated to router 9's loopback interface. All right. Okay. I think I got it. And what Dimitri is saying is on this tunnel interface, what we're saying is that the tunnel itself is in global mode, unless we were to change it like I had it was IPVRF forwarding. But we need to be able to route from global mode, from the global context, which is a loopback. All right. Okay, I think I got it. I'm going to keep going here. So now we should have our tunnels. All right, let's see. Sometimes the beginning of the phrase is not captured, like microphone is not being activated. That could be on my side. That could be some delay. Dimitri, thanks for that feedback. I often wonder about that because I've seen that on the videos on occasion. And YouTube would tell me when there was some latency on the network. So there could be I may have too much going on my link. Let me check. There is a dashboard. I know in YouTube it would tell you real time what your upload speed was. I think OBS will tell you as well. Let me see. Yeah, OBS has this frames per second and then kilobits per second. And I'm assuming that means the streaming feed. But I should check Twitch. Let me check my Twitch interface here, my Twitch dashboard, which is running in Brave. So this is the Twitch. I'm getting used to Twitch. I don't know if you've seen this before, Dimitri, or how you keep a kind of a look at your stream health. I know you can look you get a summary at the end. We have video preview, stats, maybe to be under stats. No, stream summary. Video stats. No, it's not it. Host. Yeah, I don't know how to check that here in Twitch. Oh, there we go. Okay, thank you, Demetrios. Video resolution 1280 by 720. 30 skip frames. 7-second latency to broadcaster, 10 seconds. Latency to encoder. How did you see those stats, Demetrios? I think I may know where you saw them. Because do I have a window open? I do. Okay. Yeah, this is there's a lot to learn here. Show video stats. Okay. Yeah, I have live. But the audio itself is perfect, but the beginning of the phrase is not captured like a filter in OBS that is filtering background. Oh, I see what you're saying. Yes, Dimitri, I do have a filter. As a matter of fact, let's play with that a little bit while on stream. That would be awesome because I would love feedback on that. Okay, I think I see what the issue is. So have you ever seen, here's the audio right here. And so you folks it seems to think that the video stats are good. It sounds like a video. We've had that latency looks good. 7 seconds and 10 seconds. Only 30 skip frames. That's not bad. But what I've noticed is when my voice goes down here, I think that might be what the problem is. When it turns red, that overloads the volume. I probably need to turn down the gain on this mic. Yeah, let's try that. I'll turn down the gain. And we need to try to avoid going into the red. See, right now it's the mid-range is here. And like when I go right here, it goes to red. And I think that may be what the issue is. So yeah, I'd love some feedback on that. Now I do have a filter here, Dimitri, and I'll show you. I have a noise gate. And this is my threshold. I've played with this a little bit. This is 3226, which I understand might be somewhat aggressive. It's a small window, but there is actually a good bit of noise where I'm at, unfortunately. So I got this off a YouTube video. They said try 3226, but we can adjust that. Let's, I guess let's see how that gain, turning down the gain did. And I'd love to hear your feedback on that if that has improved it. If not, I can reduce this threshold to close. Hey, guys, I just want to thank you, by the way. I really appreciate the feedback because I want the quality to be high, and I've done testing. Obviously, during the when I watch the videos later, I'll watch them later to see how the quality was. But it's hard to get real-time feedback, So I really appreciate it, guys. Thanks for taking the time to help me out with that. I like to have good quality sound where possible. And now one thing I've noticed too is, I don't know if you've seen this, Dimitri, but you see that on my head? Like, this changes dynamically. I really need some new lights. Because I have some lights that are okay, but that's why I tend to wear that little band up here, because sometimes it makes that ghost go away. We can adjust that a little bit too. Let me try to adjust that. Yeah, I've played with this a lot. There it went red again. I don't know if you noticed. The stream, the mic went red again because I was talking down here. Sometimes that helps. We'll see. I want to give you guys a good quality stream. Let's see. I've noticed you have two, Dimitri. I do. That's right. See, I always wondered, Demetrios, what you go by. Do you go by Jim, Demetrios, Dimitri, or all the above? I don't know. All right, guys. All right, so let's see if we've got this tunnel up. I'm struggling to determine how to verify the tunnel or the NHRP. I guess we can do it under VRF. Okay, Mostri Dimitri. Okay, yeah, I had a coworker years ago, was Greek, and his name was Dimitris, Dimitris, Dimitris. But he went by Jim. So another account, another app. Check the sound. Oh, thank you, Dimitri. I appreciate it. I do appreciate that. So show IP NHRP VRF underlay transport, because our NHRP should be bound to the. I'm trying to think, how do I reach? How do I validate the tunnel? I see that the tunnel is up. But if I want to test, if I want to reach the other side of the tunnel, okay, I can ping from the global. Yeah, tunnel is always up. It is MGRE. Yeah, I understand. I always like to just see it, show DMVPN. Okay. Interesting. Up, down, never. It shows peers. And I can see that is probably because I'm in global mode and the peer is in a VRF. No, it wouldn't be. The other tunnel's not in a VRF. So let's say I were to put a static route, right? Let's put a static route here. All right, from the loop back on the spoke, can you ping underlay of the hub? Okay, good point. Let's go to. Oh, that's actually in the VRF. Never mind, that's not the underlay. The underlay is, well, good question here, because Here's what they've got me doing, Dimitri, on the hub. So notice that the source is loopback 0. And loopback 0 is, so this is my underlay. It is in a VRF. So I'm not really going to be able to reach from the underlay of the spoke to underlay of the hub in VRF. Oh, okay. I did check that before. So if I say ping, if I want to ping the underlay address, ping VRF underlay underscore transport. I understand the name now. This is indeed underlay transport, right? That's what this VRF network is for. So if from the spoke, I ping using the VRF underlay underscore X transport, the hub underlay transport address, VRF address, 6.6.6.6, which is loopback, source, my underlay address is 151.45.5. Yes, I can. So, all right. What was I trying to ping here? Yeah. So yes, I can ping the underlay through the VRF. So I should be able to ping tunnel to tunnel. Ping 155.1.0.6 source tunnel 0. This is the overlay address. Okay, show run interface T0 on both. Okay, you got it, my friend. Show run interface T0. And I'm going to put this up here. This is spoke. Your DMVPN is not up in show DMV. You will not. Okay, yeah. If it says unknown, right, that means I got problems. Yeah, good point. So now in router 6, show run interface T0. So this is spoke, and this is hub. Five 105, 155.106, IP and HRP authentication. I could do a debug IP and HRP, right? Should probably be doing that. Setting route to delay for next hop server. Attempt to send packet through interface destination. Send registration request via tunnel. 0 VRF global. Sending an HRP controlled packet MBMA address. And how about over here? Debug and HRP. Sorry, I left this. You meant to look at that. Sorry about that. I just glossed right over it. Yeah, so there's my configuration. Not enough screen real estate. I know I'm using big fonts, but you know that's easier for everyone to see. Okay. So now let's try that ping again. I don't think it ever reaches there. Should I? Sorry about that, man. Yeah, my big old head, my big old bald head. And let's do this. Checking now to see if that helps. All right, I'm still in the way, I think. We'll fix this, guys. We'll fix it. There we go. All right, you don't have... that's probably the problem. But that is not the reason why it works. Okay, why it doesn't work. All right, well, let's put that on there anyway, right? Right, because we're not trying to do... we're not trying to route over it yet, right? So we'd have problems, though, once we try to run. We're supposed to do EIGRP over this. IP NHRP multicast dynamic. Map, yeah. IP NHRP map. Okay. So yeah, it doesn't look like it's even really reaching. See, here's the thing. Do we even have a... This is the address, which is a loopback. There's the IP address. And also, Dimitri, I have a route. Oh, wait a second. Yeah, they have me configured right now. Since we don't have routing protocol running, we have a static route. IP VRF underlay route. So this is our route to get there. So that's how we're sending it out that interface. And on router 6, if I do show run interface L0 or L66, this is the underlay it wanted me to use. Ah, yeah, flap. I was thinking that too. I was listening to Brian McGann's videos yesterday on INE, and he ran into the same thing. Of course, he had crypto running. So we're going to do shut, no shut. Shut, no shut. Encapsulation succeeded. Okay, so maybe we're good now. Show Dmvpn. Ah, there it is. All right, we can undebug now. I'm curious, Dimitri, have you seen this to be buggy? Is this just... I swear I've had to do... Yeah, I did it on the hub as well. I did a shut and no shut. Oh, show Dmvpn? Ah. Interesting. Yeah, the show Dmvpn is here. Do I have to do send traffic over it? Shouldn't. Ping 15105 source T0. Tunnel source on the hub is wrong. Tunnel source loopback 0. Well, here's the thing, and I thought this was strange, but I'm going to show you what it has in the INE requirements. I'm going to show you just this excerpt. Maybe I read it wrong. So we've got, yeah, R6 is a DMVPN hub and should source the tunnel from its loopback. And this is a new loopback that we have to create and assign to the VRF. I thought that was very unusual. We're using that loopback as the 66. You're right, my friend. You're so right. Interface T0, no tunnel. Well, you are the man. Okay, so now we should be good. Now we should be good. Okay, boom. Now we got to show DMVPN. Ta-da! You saved me there. Yeah, I'm so used to working on loopback 0. By the way, show DMVPN, this indicates see and show DMVPN status. Okay, so yeah, we have a status here, right? On the spoke. Oh, it did show us. Yeah, state NHRP. Legend. Yeah, stuck in NHRP registration. So, yeah, I mean, stuck in crypto, right? So we're going to see here NHRP, IKE, or up. So now it should say up, right? Yeah, up. Okay. You're the man, Dimitri. Thank you so much for helping me see that error. And now I was doing and the thing is, it's true, when I did a debug here, we should have seen it here as well, right? Already pending registration request. So this should have told us that we sent a registration request. Send registration request, but we never got one back. Retransmit delay was activated, so we sent it again. Right. And we weren't getting it back. Yep, that should have told me there as well. Man, this is good. This is a very good learning lab right here, I have to say. I've learned a lot. All right, so now that we've got over that hump, that was a big one. So we've got some static routes. We've got connectivity, DMVPN. We should be able to we have to configure router 9. I don't know if we've configured him yet. We should test spoke to spoke before we do our EIGRP configuration. Thanks again, guys. All the feedback is awesome. That's why I do this, because you guys are a big help. And I learned so much from my viewers. I really do. I really learn a lot. I love this DMVPN stuff too. I cannot wait. There's some proofs of concept. Yes, I'm going to do crypto probably last. Now, when would you normally do that, Dimitri? like I went through this, you know, I broke this lab into 4 sections. I did VRFs, then I did BGP because we don't have IGP running here. So this is kind of my transport reachability, right? So I did BGP, then I did DMVPN. I just finished DMVPN. Then I thought, well, I'll do EIGRP and then IPSec and then verification. But I probably should do this next, huh? IPSec. Because the EIGRP is going to ride over all this, right? Yeah, let me do that. Let me just configure router 9. Let's see if I can do this from memory. Actually, I may already have it. Show run interface T0. I don't. Okay. All right, let's see if I can get this. Interface T0, IP address 151.0.9. And next thing I want to do is the tunnel type. GRE multipoint. And tunnel source. 0179. Tunnel destination is NHRP. So we want to do IP NHRP map multicast 6.6.6.6. IP NHRP map 15106. IP NHRP network ID is 1. IP NHRP authentication NHRP auth. And what am I missing here? IP NHRP NHS. Next top server. Okay, got that. Then we want to do tunnel. Key is 2. And let's see. And then we want to do tunnel. VRF. Now, is that the command? All caps. Tunnel VRF, yeah. Tunnel VRF. And what is the name of this thing? Tunnel underscore underlay underscore transport. Okay. Ping 1510.6 source T0. Boom. Nice. And it is up. And show DMVPN. Cool. Now we want to do, since we're doing phase 3, we're not done yet on DMVPN. We're not done yet. IP NHRP redirect. And on router 5, IP NHRP shortcut. So now we should be able to form, well, we do that anyway. We're not sending a summary route yet. But let's see, ping 1510.5, source T0. Okay, now we have him as a peer as well, router 5. It says D because it's dynamic, right? This is static. Cool. So let's do crypto. You talked me into it. And let me see if I can do this from memory. Actually, I need to put it in my notepad, right? If we're working off a notepad here. So tunnel VRF. I'm trying to get in the habit of keeping one big notepad file as the source of the, running configuration, right? So we needed to add, what did I just add? I just added the IP NHRP redirect. And on here, router 9, we did IP NHRP shortcut. Same on router 5. Now let's do our crypto. Let's start with the hub. And let's look at our requirements. So we got crypto, ISACAMP, policy. I think it told us which policy it wants to use. No, it didn't tell us a number. Yeah, I'm going to be in a crypt if I keep going. Crypto ISACamp. I actually want to do here is pre-share authentication. Pre-shared key. And encryption AES 128. Hash SHA 256. Group 16. Crypto. ISACamp. Key. Now this is where we might be doing this. Crypto is a little different with VRF, right? Instead of the Criso, and I'm looking at your stuff, Dimitri. We need to do a key ring. Yeah, this is where this is going to be a little different, right? So we want to do crypto key ring. And does it tell us what we need to call it? Right, Crypto ISACamp key. Yep. And I'm looking at your presentation, my friend. Slide number 39. Crypto keyring. We'll call it underlay. And VRF. Oh, maybe we want to do that. Keyring 1. VRF underlay underscore transport. And pre-shared key address. Now we can use a prefix here, which we want to do because we're going to be doing spoke-to-spoke tunnels as well, right? So 151.0.0 and 2525250. Key is, what did it tell us? Dmvpn underscore PSK. And I believe that's word wrapping here. It is, okay. Oh, yes, 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 that is true. Right, we are encrypting at the tunnel interface. VRF is the underlay. So yeah, we don't want to do that. We want to do it. That's right. So I guess we would need the crypto. Crypto is done between underlay IP addresses. Right. So you're telling me, yeah, this is the tunnel interface. That's true. And Brian McGann said that too on the video. He did say that, yeah. So yeah, this will be the crypto in the case of router. Now this is router 6. And the underlay addresses for him will be yeah, the NBMA address. So this is going to be 151.45.0. Right, but we're going to encrypt, so this would be, we still need, this doesn't have to be DMVPN or VRF-aware, right? It's underlay, crypto's being done before VM, crypto's done between. Okay, we're going to go with that, I guess. I think that's what I need. I also need, this is going to have to be zeros. because we're on multiple subnets for our underlay. On the spokes, it would be different. I think that's what I need to do. All right. We'll try it. We'll try between, yeah, I can add multiple subnets. Okay. Well, that's definitely preferable. 155.1, yeah, let me look that up, because I have never looked this in the command reference before, and one thing it did say in the video is that for all these, we definitely need to read the command reference for these commands. Yeah, it's supposed to be more or less the same because you also do spoke to spoke, right? So we should be able to basically copy paste, right? So let me go to the command reference on this. And this will be under security, I believe. Security view, yeah, crypto. IPSec. And this is, what's this command? Keyring, crypto keyring. Let me just look at the options here. Okay. To define a crypto keyring to be used during IKE, use crypto keyring in global. VRF is optional, front door virtual routing and forwarding. Hey, it has its own acronym. FVRF. The VRF keyword, okay. So pre-shared key, address, blah, 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 key. Yeah, Krista IPSec, okay. And that goes under the, we're not using a profile here. That's all it says. Okay, well, that's not a big help. All right. So let's do one for that subnet. This is the main problem with Dmvpn plus pre-shared, right, versus PKI, right? Most likely end up 0.0 because you don't know underlay of all the spokes, right? Imagine 1,000 spokes. Yes, this means that anybody can now build IPSec tunnel with you theoretically. That's why PKI is preferable, yes. But it's additional administrative overhead. And they talked about get VPN as well. That sounds like it would be much better. But of course, that's not covered, I think, in the lab. It's not part of, well, at least not route switch, right? It's probably part of security. But yeah, you're right. This is a big problem. I can see that. Anytime you use a pre-shared key, really is kind of. All right, so this will be one of our spokes, 151. Actually, this will be 15.1.45.0, 255.255.255.0, and then we're going to put, yeah, it's a key ring, right? So that means multiple keys. Makes sense. And this is pre-shared key address. This is going to be 151.79.0. Okay, cool. So that's our crypto IPSec policy. I'm not sure how that's applied. I guess that's applied. We created the key ring, but do we associate that somehow with the policy? I get the crypto key ring. I get the impression here. Okay, you don't need to apply it. All right, so it figures it out. Thank you, sir. Okay, my phone thinks that I'm talking to Siri. All right, so that's the IPSec policy. Now we can do the crypto IPSec transform set. And create phase 2 now with profile. Yeah, it should work. Okay. We're going to go for it. And our requirements on this are crypto IPSec transform set. think it wants us to use a name. It doesn't here, but our policy is going to be AES. It's, I think, ESP AES 256, ESP SHA. This is probably HMAC. I'm going to have to type this at the command line. Crypto, IPSec, transform, set. And the name, did it have a name it wanted us to use? Oh, it wants a single VRF-aware wildcard pre-shared key. Yeah, that's what we did. Okay, it doesn't specify. So crypto IPSec transform set AES 128 SHA 512. We'll call it that. And it's ESP AES 128 and ESP SHA 512 HMAC. That's, I always forget how to word that exactly. So that's going to be our config here. Okay, IPSec, and then crypto IPSec profile. It had a name for us to use here. Dmvpn underscore profile. Set transform set AES 128 SHA 512 and mode transport. Okay, good deal. Then we need to apply this to the interface. Tunnel protection IPSec profile. And I'm remembering a lot of these commands. That's good. That's practice. Dmvpn underscore profile. Okay. All right, now we've got to deal with our overhead, our encapsulation overhead. I have not done that yet. So we need to put that here. Yeah, we're going to say IP MTU 1400. Now, I don't think I need to use 1400. I think, isn't it like 1460 IP TCP? Yeah, we need this. You're right. This has to be higher than that. Yes, sir. Good point. Very good point. Okay, that should be, let's put that here. You know, I don't often think about that, Dimitri, and I should. I should be thinking about order of application because when you're doing large labs, right, you have to be efficient. And you don't want to have to paste things twice if you can help it, right? Very good point. So IP TCP MSS 1420. You can't use 1460. Yeah, often they do 1400. That's what I've seen a lot in the INE lab answer keys. That seemed to be a little too aggressive to me, though. Like a little too conservative. But I've never actually figured out exactly what the overhead will be. You know what? We'll do a capture after this. We'll do a capture. In lieu of actually looking it up, we'll do a capture, see if we can figure out. You probably know off the top of your head, Dimitri. I wouldn't doubt it. It is also, oh, it is. Okay, it is a recommendation for Cisco Doc. Okay. Okay. Well, that's why INE does it. That makes sense. All right, we need to do that. So that should give us what we need for the hub encryption. So now we need to address this on our spokes. And I'm wondering about this. Use a single VRF-aware wildcard pre-share key. I want to meet these requirements. Let me look back at that and just reread that and make sure I'm doing what it asks. Use a single different encryption algorithm will result in different overhead. Yes. Good point. Very good. Oh, you're talking about like if I used SHA-512 tool on Cisco. Oh, yeah. I've heard about that. That's a good point. I'm going to put that as a later a to-do. I'm going to do that as a to-do and check that. I think that might have even been referenced in one of the videos. Now it's saying it wants a single pre-shared key wildcard. So just to be compliant, I think I am going to have to do all balls here. Man, that's horrible too. I could just do 155.1.0.0. That would cover me right there. At least I've got something. Oh, thank you, Dimitri. Let's pull this up. Let's pull up this. Hope the sound's okay right now, guys. Let me know if you still have a problem with that. I've been kind of watching this, and I'm not hitting the red too much. I think red is since I turned down the gain, that seems to have helped. So, oh, awesome. Okay, that was it then. The gain was too high. Okay, on the spoke, you need to also have, yes, because that's the underlay. Man, that's going to be wide open. I think, though, that the requirement is let me look under the crypto requirement again. Use a single VRF-aware wildcard pre-shared key for all Dmvpn peers. Oh, unless somebody prohibits. Okay. Yeah, I guess I was maybe getting a little greedy here. You know what I need for this stream is I just saw this green box jump to orange for a second. You might have seen a delay. I've seen some streamers, Dimitri, that have a running, like up here on their screen, they'll have a running response time meter. And I don't know if that is like to one of the Twitch servers, but I want to get one of those. I want to put one of those on my stream too. Running latency streamer, latency counters. Okay. Something to research, right? Something to research to improve the stream. Okay, so here's our, not to get too... Okay, this is cool. I like this tool. Original packet size is assuming 100. Tunnel is GRE over IPSec. Tunnel key. We do have a tunnel key. IP4. We're not doing NAT traversal here. Tunnel mode is transport. Nice. Encryption. AES 128.192 or 256. I want to see how this changes. Wow, 512. Okay. So this integrity, this is really sweet. Total IPsec packet size 100, so it takes up 88. Because if we do 1400, wow, so that's perfect. 1402. Well, there's padding, right? Oh, here's a pad length. This is cool. I like this. So it looks like this is pretty big, this integrity of 512, ESP SHA-512. I'll bet MD5 is pretty low. Not much difference. Yeah, there's not much difference here. Okay, yeah. Yeah, thank you for sharing that, Dimitri. That's awesome. I'm going to link that in the description. All right, so getting back to what we're saying, yeah, I don't know. It would make sense, especially in the lab, right? Where in the lab you're just trying to get functionality to use all balls. Unfortunately, I think that's all I'm going to be able to do here. The requirements are kind of restricting me to that. All right, so let's do this on the spokes, which would be router 5. All right, crypto keyring, VRF, same, pretty sure key. See, I hate doing this, but not much of a choice. And then our interface, we need to modify this. We need to say tunnel protection, IPSec profile, Dmvpn underscore profile, IP MTU 1400, IP TCP MSS, adjust MSS. I need to check that. I always get that wording wrong. Okay, I had it right there. Oh, that's router 5, but I think on router 6, yeah, IP TCP adjust. And next we need to do router 9. So let's paste that in here. This is fun, guys. I'm having fun. I don't know about you. I like this DMVPN stuff. DMVPN. I'm enjoying this. I never thought I would say that, you know, anytime you talk to a recruiter, which I'm not actively, you know, talking to recruiters, but when I was searching for this job that I have now, every recruiter was like, do you use security? You want to do security? And I was like, no, I can't stand security. I don't enjoy it at all. I just didn't know enough about it or see all the different use cases for it. So in relation to routing. So now I'm a lot more excited about it. Okay, so we need to adjust. That's router 9. So we got our policy. We have our transform set on router 9, the spoke. Now we just need to update the interface, tunnel protect IPSec profile Dmvpn underscore profile, right? Yeah. And then IP MTU 1400, IP TCP adjust MSS 1360. Okay. That should do us, right? So let's go ahead and pop this configuration in. I'm just going to go ahead and do all of this on router 6. If I were more confident, I would just wait to the end to paste all this in, but I'm still green, guys. I didn't mean to do that. No. Okay. All right, group space 16. All right, we got a few more errors we need to fix in here. I think I see where they are. Group space 16 and IP NHRP map multicast dynamic. Where else do we get an error? Mode transport. Crypto IPSec set transport set. Tunnel mode transport. Let's see. First of all, let's just fix these errors. Yeah, it's part of transform set. I thought I had So this should go into transform set configuration mode, right? Let's put that in there. And then it should be mode, or tunnel mode, maybe? Oh, set. So I don't have mode here. Crypto IPSec profile. Mode transport goes to crypto IPSec. Oh, gotcha. I'm with you. I'm configuring this under the policy, but I should be configuring this under the transform set configuration. I'm with you now. Okay. Good catch. All right. There we go. That made him happy. And let's go back and do this. Okay, group 16. And we need to correct. Okay, let's just paste the whole thing in here. Already exists. Yep. Okay. Good deal. All right, so now let's go to our hub. Router 5. Let's correct that. And correct this. And yeah, this should all be good. Okay. So we should now see a tunnel form. Ping 150.1.155.1.0.6. Wait, that's the wrong IP. I don't want to ping that IP address. I want to ping... what should I be able to reach? The tunnel address. Show run interface T0. Yeah. Ping 155.1.0.6 source T0. Oh, did I put the... I did put the pre-shared key here. Okay, so let's do show crypto IPSec SA. We are in clear Dmvpn. Clear Dmvpn session. Okay. I've never used that command before. Clear. All right. You know, I saw a CPU error here. In critical region interrupt level, traceback, net background. I don't know what that is. I want to shut down a router or two that I don't need, that we're not using, just in case. And we don't need these switches running either. These are part of like the template and they always boot up. But just in case. Okay, we should be pretty good here. All right. So yeah, show crypto IPSec SA ident. Okay, show IPSec or crypto ISACamp. QM idle and active, so that is good, right? Show crypto IPSec. Let's do. We should be good here as well. Yeah, we are. Show crypto IPSec. It looks like phase 2, right? Flap the tunnels. Yeah. When all else fails, flap the tunnels. This happened. In fact, in the video where I watched this, it was an unrecoverable error. He had to actually reload, I think. Shut. No shut here. And no shut here. Okay, let's generate some traffic. Let's do a, should we do a debug, or let's look at our configuration first, right? Show run crypto. Phase 2 is working, but the device does not encrypt the traffic. Show crypto IPSec SA, okay? Show crypto IPSec SA. Protected VRF. We should have something here, right? Inbound. Send errors 10. Send errors 10. Should we do a debug? Debug. Yeah, phase 2 didn't form, right? Tunnel 0 head 0 local address. Compare crypto on both just in case, yeah. Send errors, remote. All right, local tunnel endpoint, remote crypto endpoint. That should be correct. Why is PFS? Oh, no. Yeah, PFS, no. Okay. Show run section crypto. Let's just take a look. Show run section crypto. Crypto IPSec transform set, AES 128, SHA-512, ESP AES, ESP5, HMAC, mode transport. Dmvpn underscore profile, set transform set, AES 128, SHA-512. Yeah, man, these look the same. Show run interface T0. Show run interface T0. Tunnel protection DMVPN underscore profile. Show interface T0. Tunnel is up. Encapsulation tunnel. Tunnel transport MTU. Just reload. Yeah. All right. Tunnel protection over IPsec. Yeah. All right, so let's do this. Let's do a show run. Yeah, unfortunately, this is not. Yeah, let's do that. So let's do right. And let me copy this just in case something. Well, I've got it here. I've got it here. Reload. Yes. Man, do you find this happens a lot in production? Or is this just virtual environment? I mean, I've seen, I have to say, most of my crypto work has been on Cisco ASA platform. And I have seen issues before, like I think we talked about this. We're talking about this with Doug in the Discord channel the other day. He had a crypto problem with an interesting access control list. And that was my thing that, suggestion was, well, just reload, because I have seen that before on the ASA platform. And the mistake I've made in the past is being it was a little arrogance, maybe. It was a little, stubbornness. I kept working on an issue with the tunnel. And finally, after like 2 hours, I did a reboot. Fortunately, it was a new configuration. It wasn't anything that was in production at the time. But I just reloaded. In fact, I think we had called TAC, and they said the same thing. They worked on it. They said, just reload the thing. If you're not in production, reload. So we reloaded. Tunnel worked right away. Probably just the nature of the beast, right? But I've not had to do that often in production, even on the ASA. It has happened from time to time. I have had to do a number of instances of remove the configuration and then put it back. So I have had that come up. But I will say, working on router IPSec tunnels, that so far, at least in Viral, in the lab, in these very small topologies, there have been quite a few apparent bugs. So I'm loving the technology that I'm learning about. I'm just hoping there's not any sort of reflection on what it's like in production. Because this would be a pain. Okay, good. Yeah, it's. I would assume. I mean, they've got it down to where so much of this is even happening. The forwarding is, and the processing is happening in hardware. So it would seem to me in that case that this is a very stable, proven technology, right? It's used everywhere. It must just be the fact that it's virtualized in a lab running in software. Okay. So let's see what our configuration is now. Okay, it retained everything. Good. Show crypt. Let's send some packets. Ping 15106 source T0. All right, nothing yet. Show run interface. Let's see if the configuration. Okay, it's there. Crypto. Make sure everything is still there. I have seen this issue on occasion of Viral. Okay. Everything looks like loopback is wrong again. Okay. Well, that must have snuck back in there, my friend. Yeah, I did not correct it in Notepad. 5 slaps for entering a configuration live on the router and not updating what should be the source of our present running config, and that is in the notepad. So shame on me, but let's go back here. Router 6, tunnel source. Yeah, tunnel source loopback 66. All right. Yeah, it snuck back in there, didn't it? Actually, that may have been the problem before. That's probably the issue before. Because I did come in here and copy and paste again. Okay. So now let's try it again. Booyah. Now, what we're using here, you did include, what was that command you used, Dimitri? Ident and caps. I like that one. Show crypto IPSec SA. I like that. Okay, we're going to remember that one, folks. Okay, we're good. So now we need to do router 9. Okay, I didn't take these errors out here. Group 16. And this goes here. And we had another error. IP NHRP map. Okay, that's there. That's correct. What didn't it like? Group 16, mode transport. That's it. Okay. Let's fix that. Okay, TAC VPN team. Yeah. Who knows? I may have actually talked to you at some point, Dimitri. I don't know if you covered if you did routing VPN. Probably not. I did work on a couple of ISR VPN issues. We had some small offices with small ISRs. But generally we had ASAs, at least in my last company. Okay, good deal. Good deal. All right, so now show Dmvpn. Okay, IKE and NHRP. All right, so we're not set here yet. What do we got going on here? Tunnel mode, show run interface T0. NHRP, okay. Ping 15106 source T0. Okay. This still says IKE. I haven't seen anything yet there yet, I don't think. Let's do, based on our static routing, or just our tunnel routing, 15105 source T0. Now we should lose a packet or two, and then we lost one packet, and now we have a spoke-to-spoke tunnel. Yes. All right. All right. So now we have our tunnels, and we have include ident and caps. Yeah. So we have 2 tunnels. Good. All right. Whew. We're getting farther. We're almost there, guys. I think. Now we just need to configure EIGRP so that we can send loopback traffic from 5 to 9. So the configuration for that, let me see if I've got this right. Now, originally I was thinking this needed to be, all right, so EIGRP, I think as long as we include the tunnel interface in the EIGRP process, that will take care of being able to form our adjacencies. In other words, we don't have to do anything crazy in, everything can be an IPv4 unicast, right? Because we're going to be routing EIGRP in global context. not under the VRF. So yeah, we should be able to form an adjacency directly with router 6. And then I think router 6, is he supposed to do a summary? Yes, router 6 will only send a default route. Okay. All right, so there's a couple things we need to do. Let's do router 6 first, the hub. And we'll set him last, right? This is going to be router EIGRP DMVPN, address family, IPv4 unicast, autonomous system 100. And we're going to do AS100 on the DMVPN interfaces. So I think what they intend for us to do here is do AF interface default passive exit, and then AF interface T0 no passive exit, and then network 155.1.0.0, and then we need it's going to redistribute connected automatically, so it's going to redistribute our loopbacks. That's all we need to do. Well, this is the hub, so there's a couple things we need to do in DMVPN phase 3. One is we need to disable split horizon on the tunnel interface. No IP split horizon. And in this case, let's see, do we have to do no IP next hop self? We do not. Not in phase 3. Okay. Yeah, I think that's what we have to do there. So, anything else? Oh, no passive. I believe, yes, that's right. Okay. Okay, router EIGRP. Okay, very good. I think that's all we need there. So now let's go to the hub or the spoke. That was, boy, that's a long configuration. There's a lot of, I'm not sure what, okay, that's right. So router, EIGRP, DMVPN, if interface passive, yeah. We don't need that here. Same network. Okay, and then we're going to take this and put this on router 9. And we should be good to go. All right, let's try it out. Router 6, we'll paste the configuration into that router. We don't need IP split horizon. It can just be no split horizon because we're in AF mode. Okay, then router 5. And let's see if we get a EIGRP neighbor notification. Yep. Show IP EIGRP neighbor. Good. Show IP route EIGRP. Not learning anything yet. We should be learning the loopback interfaces. All right, let me think about this. Tunnel, router in global mode. Yeah. Oh, it's passive, right? Those interfaces will not participate in EIGRP, but I should still be redistributing connected interfaces. Show IP protocols. All networks, incoming. Yeah, I don't think I need to type that. Router EIGRP DMVPN. Let's look on router 6. Show IP route EIGRP. Show IP EIGRP neighbor. 0 tunnel. Okay, up. Show IP EIGRP topology. Okay, I guess I need to put that command in there. Yeah, I'm not sure why that let's see. Let's go to router 5. Router EIGRP DMVPN. Address handling IPv4 uni 100. And topology base. Redistribute connected. Okay. Yeah, I didn't think I had to do that, but I guess I do. That's, you know what, I don't think that's what it's asking us to do. Advertise loopback prefixes, loopback 0 prefixes into EIGRP. Well, that accomplishes what we want. All right, so we need to add that to the configuration. Let's say topology base, redistribute connected. I don't know. I'm not feeling that, guys. I'm not feeling that. I think what I need to do is just put a network statement here. Network 150.1.0.0. Yeah. Let's do that. All right, this is router 5. Yeah. I don't know. For some reason, I feel more comfortable doing that. First of all, it should be an internal EIGRP route, not external. Okay, same here. We want to say network 150.1.0.0. All right. That will go on router 6. And finally on to router 9. Okay. Oh, sorry, router 9. Need configure terminal. All right. Sweet. So now show IP route EIGRP. Okay, now notice that the next hop here is 155.106, right? To get to this other spoke. However, this should, through NHRP redirect, we should not go through the hub for this. And once we send traffic there, we should see that happen. We should see an NHRP route for this. 5.5 source L0. Okay, we have reachability, which is good. Notice that this is what we want to see. We have a next hop override. Awesome. Yes, it's working. In fact, if we do show IP NHRP, or no, show IP route NHRP. Booyah. I love it. Good stuff, guys. Good stuff. All right. Yeah, Dimitri, you're very good at troubleshooting this stuff. You must have done this a time or two. I can tell. It's like working with TAC, with having you here. We've got TAC here on the stream, guys. My dream has come true. TAC is in my lab. I love it. All right, so I think we're done. Let's just check our verification. Router 5, 6, and 9 can reach each other's loopbacks over DMVPN network. Let's just check all that. Yeah, XTAC, I understand. I was kind of being facetious. We should be able to reach this loopback as well. And we can. Good. Let's look now. Router 5. Ooh, thank you, sir. Yep. I did neglect to do that, didn't I? Because the purpose of it is a requirement, and that's the advantage of phase 3, right? Is to be able to summarize, hide the topology. So we are missing that, and we need to put that on router 6. I'm getting lost in lines of code here, guys. It has turned into a sizable lab for me anyway. We want to do this under AF interface tunnel 0. We want to say IP or summary address 0.0.0, Yes, good call out, my friend. These are the kind of thing that noticing these things is how you save points on your lab, right? Okay, so now we should reset or resync. And hopefully we don't have to reload the router again. Oh, did I put this on router 5? I did. That was not smart. That was not smart. Now I might have to reload the router. Yeah, 0, exactly. All your IGRP points would be gone. And we put it on the wrong router anyway. We put it on router 5. So what we're going to do here is we're going to say no router EIGRP DMVPN. Okay. Let's try to do it on the correct router this time. Okay, good deal. Resync. Did we resync with router 9? Just now? Yes, okay. So let's check. Yeah, dual recalculated. Oh yeah. And now let's do... Hey, thank you. And that's thanks to you guys, really. That's thanks to all the great interaction with the chat, which has made this just an awesome ton. I appreciate you helping me with the stream stats there too, Demetrios. I'm going to try to continue to make it better with you guys' time. And I know it's really late there, and probably for both of you. So, yeah, I'm about to end. So thanks for hanging out, Demetrios, and good luck on it. How many days left? You got like 9 days before your written exam. So good luck on that, my friend. Keep us posted. Always appreciate the great support I'm getting here in the stream. It's been amazing. Show IP. Thank you, Demetrios. Thank you very much. So yeah, what we notice here is the route, because we're in phase 3, this is the only route we have, right? But we still have a show IP route in HRP. We do have an override here that says, notice the next hop. So we're not going to use this for the next hop. We're going to use this. And another verification step we can see is if we look at our crypto tunnel, show crypto IPSec SA, include, shoot, what is it? Ident and caps. We should see this increment, right? So if I ping yeah, so we incremented our the packet counts on this tunnel here, this identity tunnel, spoke-to-spoke tunnel. So what else is our verification? Yes, it does not transit the hub. We have validated that. And ensure reachability is maintained if router 6 loses the peerings with AS100 or AS200. So this is new for us too. This is the BFD, and we have BFD configured. This is incorrect. Let me check these requirements. I've got a line here going through 2 routers. That's not right. BFD should be in our BGP section, router 6 to router 1 and router 7. Yeah, I think that's just my mistake there. Yeah. So we just have BFD here, but we want to test the BFD failover in case we lose this peering. And there's a couple ways this could happen, right? What's going to happen, as we talked about, in this virtual environment, it's not always easy to replicate this, or to duplicate this scenario. But we're going to be able to duplicate it here because if this is using a sub interface through a switch. So if we shut the sub interface down on one side, router 6 will still show that his physical sub interface is up. So this is a great way to demonstrate the use of BFD, which should be running. Let's double check that. And we're going to shut this down first. Let's double check here. Right now, if I go from, let's see, I'm trying to figure out how do I verify the path that we are taking now. I mean, I know from looking at the diagram, but I guess I could do a trace route from the underlay address, right? Well, we know this is coming here. So I could look at router 4. Yeah, I could look at router 4 and see what his path is. Show BGP, IPv4 uni. Okay, so we know, for example, for this tunnel to work, I may have done the wrong interface here, guys. I think I was supposed to use this one. Huh. Yeah, I may have done that incorrectly. The underlay trace. Yeah, you know what? I think this... See, we've got BFD here, and I think it wants to simulate taking down this peering, because router 6 is not even peered with router 4. Let's just double check. Let's double check. Let's not guess, right? Let's validate through router 5. Right, here we are, router 5. And let's do a trace route. VRF. Man, I can't just, what is the name of it? Underlay transport. That's a long name for VRF. Trace route, VRF under. And we want to trace route to, the source is 6.6.6.6, or the destination. And the source is 15.1.45.5. Yeah, we're going router 4 and then router 6. Yeah, so router 4 is going to go this way. Why is it going this way? Let's look at router 4. Because it's VRF, right? The next hop is 6. show BGP IPv4 uni summary. Okay, so I have learned router 1 has advertised, but we're not doing next hop self, are we? Yeah, we're not doing next hop self, and I think we should be in this topology. Because this is eBGP. And it's rare that we would have a connection like this and not peer. Yeah, interesting. 151.45.0. I have a feeling that it wanted me to go this way. Let me look back at the requirements here. All right. I need to look at this closely. In fact, I'm going to look back at the workbook. Assign the VRF on router 5's link to router 4. It actually has 2 links to router 4. Oh, it does not. Okay, we're good. This is right. Okay, so let's do our trace now to this underlay address. Yeah, maybe the scope of my trace is, if I want to take into consideration BFD, then I really need to trace all the way to here, don't I? That's what I'm doing wrong here. So let's do that. We want to go to the destination is 155.1.70.9. Okay, there we go. All right, this makes more sense. Because again, this traffic is going to be spoke to spoke, right? So it's going to go to router 4, then the router 1. Let me do this side by side here. Yeah, 5 to 4, 4 to 1, and 1 to 3. Okay. And then to 7, and then to 1. We're using these eBGP and the 7 to 9. Okay. So boom, 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 boom. Makes sense. Yeah, spoke to spoke. That's where we would want to go. All right, so what is it proposing that we check? Ensure reachability if router 6 loses its peerings. Well, we need reachability to the hub, right? So let's try this. What if, this would probably be a better test. What if router 9 wants to send traffic to router 6's loopback? Yeah, let's use that as our test. So router 9 wants to send a loopback, and to do that, let's trace from the VRF to VRF. So we should be able to trace route. Will 6.6.6 work? Maybe. Yeah, it's in the VRF. That should work. Trace route 6.6.6 source. I need to do VRF here. Trace route VRF. I can never remember the name of this thing. Underlay transport. Underlay transport. Destination. Source. Okay, so it goes router 7 and then router 6. Okay, so what if we lose this? So let's emulate that. Let's go to router 6. Let's run a continual ping here from router 9. Let's do a ping and repeat. No. Okay, and then let's go to router 6. And we'll shut down the subinterface. That's actually this. I know the line goes that way, but it's really this 67. BFD session destroyed. I love it. All right, so BFD came into play because notice on router 7, we should see that interface is still up. Yeah, look at that. That interface is still up, which is, this is a perfect example of the real world. You know, again, even at your layer 1, you've got other gear in line. So the interface may be up, but doesn't mean you have physical connectivity, right? And in this case, we do not. The interface is still up, but instead of waiting on the BGP timers to expire, we have BFD in place. We only lost 1 packet. That's awesome. That's what we want. Look at that, only 1, and we have a failure. Now let's turn BFD off and see the difference. First of all, let's bring the interface back up. Interface GI 00167, no shut. And let's turn off BFD. Let's turn it off in the protocol. Show run section. We've got it up here, but I just want to see it here on the router. It's way up here. Yeah. So let's take it out. Router BGP 6, address family IPv4 VRF underlay underscore transport. No neighbor 151.67.7 fall over BFD. And it's doing a router 7 too. Oh, look at that. BFD syslog down reason. Yeah, it's two-way, right? So router 7 knows BFD is down. It's two-way communication. That's how it works. All right, so now let's do the same test. And let's shut down that interface. I guess BGP had come back up. Okay, what a difference here, right? As far as 7 is concerned, this is still the next hop, right? It's still valid and best. And if I do show BGP IPv4 uni neighbor, BFD is configured, BFV peers down, using BFD to detect fast failover single hop. But guess what? That doesn't do us a lot of good because the interface is showing us up still. Hold time is 180. Keep live interval. So BGP's still up and we're still dropping packets. Now EIG, see this is just this is a cluster, right? Because now EIGRP is faster than BGP, right? So EIGRP hellos are going to time out first. And now we're going to have to send query packets. Well, I think that's our only neighbor. Router 9 is router 7. That's our only EIGRP neighbor is through routers, yeah, through the tunnel. So we've lost our EIGRP. We are still probably waiting for BGP to go down. So yeah, this is last read 0220. Let's see, we gotta wait a full 3 minutes, and meantime our phones are rebooting, right? Phones are restarting at a remote site. Our Citrix sessions are dropping. Like we could have rerouted, but you know, this is, we're done for, right? Okay, how's our, yeah, our pings are still down. So yeah, that's way too long to wait, right? So, good stuff. Well, folks, I think we have pretty much wrapped up this lab here. This is a long lab for me. There we go, BGP notification sent. Now we should start to reroute packets. But see, that was just way too long. Phones are blowing up now at the help desk, right? Yeah, egg on our face. So this is something very important. Good stuff, guys. I'm trying to think what else we need to talk about before we wrap this thing up. Yeah, a lot was learned, and when I'm going back through the configuration and I'm kind of reflecting on this lab and some things learned, one is I've never done BFD, and I've never done an underlay in VRF. And I see the value of this. I would almost like to, you know, we've taken up a lot of time here, but I would kind of like to do a typical use case for this might be multiple VRFs, right? But anyway, this was cool. This is a great lab. This is new for me, but we learned how to do that, and we also learned you really have to separate in your mind the routing when you're in the global routing table and when what you're doing applies to a particular VRF routing table. That includes the encapsulation and the encryption. Very important. BFDs, really cool feature. I really like it. Not too hard to configure. And what else did we talk about? Yeah, EIGRP. Yeah, good stuff. And I really want to thank everybody who is here. Try writing DMV+ in Notepad for memory together. Yeah, that's, I need to learn. I need to do this lab like 8 times. Yeah, I'm gonna work on that, Dimitri, definitely. And here's my plans, right? Here's where I'm at. Let me pull up this checklist, and guys, if you or gals, if anyone needs to access this, this is all the INI labs in the INI workbook, in the order that I'm pretty much attempting them in and have attempted them in. So we've got this practice column. Okay, the reason Dmvpn VRF is used is to make sure you don't have tunnel recursion problem, which is quite dangerous. So are you talking about learning? When I think recursion, I'm thinking of I guess I'm not sure what you mean there. Like, I know that there's it's common to, if you learn a route through a tunnel that you're trying to route the underlay to. Is that what you mean? Yeah, when you learn underlay over an overlay, exactly. So the VRF is kind of helps you prevent that, it sounds like. It's kind of like an insurance, sounds to me, where you're segmenting your traffic to ensure that it goes to the correct process. That makes sense. So is that common, I guess, Dimitri? Or you see that? You know, because in this scenario, you know what I was thinking at first? When I think VRF, I think of multi-tenancy, right? Like I thought of a VRF on this side of the routing. So in the overlay, for example, the BGP, configuration, I think of that being used a lot in that case, PE to CE, where if you're the PE router, your underlay network is your core, but your, so to speak, but the overlay for the customers is through a VRF. But in this case, we're kind of the reverse, it looks like. In this case, for example, if I'm a customer here and you had your P100, my traffic is in the overlay network, but the backbone or the NBMA traffic is, the underlay is in a VRF. So you're saying that that's a protection mechanism, I guess. So you ensure that you're only going to learn routes that's inside, in the underlay, you're only going to see traffic coming through another underlay. Yeah, I think that seems to make sense. Certainly. Good deal. Yeah, I do want to study some more about topologies, DMVPN topologies, and to be honest, I have not seen a lot of information about that. Maybe I need to look at a design guide. This was referenced by Brian McGann. This is great that we've done some configuration and that we've learned the configuration, but I really want to study more of the use case, the design cases for DMVPN, like this one. He did mention, let me see if there's a design guide here, because if there is, I may be reading this tonight. Let's see, that would be under the technology, would it not? Need to go under support. Let's go full menu. Or I could probably just Google DMVPN design guide. IPSec architecture and implementation. Yeah, it's not really there. It's under tunneling, right? IP tunneling. I call myself looking under this before. A lot of this seemed old. Basically, underlay and overlay serve different functions. So you don't want to mix those two networks in one routing table. You don't want... Okay, yeah, so you're kind of separating... You're separating the transport from the transported traffic, it sounds like. The transport traffic, you never want it to become transported. That makes sense. Let me see, design guides, here we go. Under IP tunneling. VPDN, no, thank you. DMVPN design guide. I thought this was referenced. Okay, here we go. Yeah, this was referenced as well by Brian. VPN WAN technology design guide, that was also referenced. Integration testing insight. How old is this thing? Scalable DMVPN deployment and implementation guide. Hierarchical hub, DMVPN design. Yeah, I'd like to look into this some more. 6500 branch designs. All right, good stuff. If whatever I find out, I'll post some links to this stuff, guys. But again, thanks very much. I really appreciate it. So the plan is we've done this lab here. Today is 21. The next section I have is multicast. This is my last DMVPN for this first run. Again, I am going to come back. I am going to practice this over and over and over. But I'm going to do a little more research on DMVPN use cases and tunnels, designs, and there are some videos about convergence. I'm going to watch those next. A little bit of that was in this particular lab, the BFD. That is one of the videos which I have not watched yet. And here we go. I need videos. Convergence optimization. So the 5 videos here: EIGRP, FRR, OSPF LFA, BFD. Yeah. So I'm going to go over those, and then I may do some of my own labs, like we did some BFD stuff today. I may do some other labs for that, because there's none in the workbook for convergence optimization. At least there's not a section for that. So multicast may start sometime this week, but you know, if all goes well, we'll be labbing tomorrow as well. And it'll either be a new convergence lab or a review. In my review labs, I'm in the EIGRP section. I think I've got one more EIGRP to do. Then we'll be reviewing some OSPF sections. But yeah, it's going to wrap it up for today, folks. Thanks again so much for all the help. Everybody in the chat, Dimitri, you're you're doing some great mentoring, man. I really appreciate it. And that's going to about do it. Thanks, folks, for joining the Land Tamer stream. Feel free to follow. If you haven't already, follow us on Twitch, so you can see when you can get alerts as well to see when we go online. Follow Dimitri as well. He's got a great channel. And we'll be back tomorrow. I plan to do some labbing tomorrow night, if all goes well. And follow us on Instagram, Twitter, all the above. Yeah, thanks so much, Dimitri. Appreciate it. And you guys have a great evening, and happy labbing.